This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. Here's how to remember the Maclaurin series for the following functions. So the functions are e to the x, and then the way that you learned your trig in that order, sine, cosine, and tangent. And then the last one is just 1 over 1 minus x. So we have f of x is equal to e to the x, f of x is equal to sine of x, f of x is equal to cosine of x, and then f of x is equal to actually arctangent of x. That's what we care about. And then f of x is equal to this. So what are the Maclaurin series? Well, they're series, so they all have sigma. They all have n is equal to 0 at the bottom, and then they have infinity at the top. And this is how I think about it. If you ever listen to that Meghan Trainor song, from the bottom to the top, so you start at the bottom, it's just x to the n, you're done. And then you go all the way to the top, from the bottom to the top, x to the n, again, same thing, but you're just dividing by n factorial. That's it. You're done with these two. Now we focus on these three. All of them are fractions. They're all alternating, so you're going to have negative 1 to the n. They all have x to 2n, x to 2n, x to 2n, and then they also have 2n at the bottom. Now what's the difference? These two right here, sine and tangent, they're plus 1 series. So you're literally just adding plus 1 anywhere you see an n. And then the last thing is the first three series have factorials in the denominator. So factorial, factorial, and factorial. And that's it. Those are your Maclaurin series for these functions. And then you can figure out the rest later, right? So if we start here, based on this, n is equal to 0. If you plug in 0 here, anything to the 0 power is just 1. So the first term is 1. And then plus, because it's a series, right, you're adding. What's the next term? Well, you increase 1. It's just x to the first power, which is just x. What's the next term? Well, then it's 2, x to the second power, then x to the third power, then x to the fourth power, and so on. You can see the pattern. So it's not like you have to memorize this as well. You just have to know this, and then just plug in your n values to find everything else. Here we start at 0. Anything to the 0 power is just 1. Here is 0. 2 times 0 is just 0. We're just left with 1. X to the first is just x. And then here we have 2 times 0 is just 0. We're left with 1. So 1 times x over 1, that's just x. Then you move on to n is equal to 1. You plug in 1, 1, 1. Negative 1 to the first power. Well, that's going to be negative 1. Then 2 times 1 is 2 plus 1, that's 3, so x cubed. And then 2 times 1 is 2 plus 1, that's 3. So we have negative x cubed divided by 3. And then because you know it's alternating, you know that the next sign is going to be positive. And the next sign or the next term is going to be negative because it's alternating. That's what this alternating tells you. Let's try one more. If it's equal to 2, well, negative 1 squared, negative squared is always positive. So that's just going to be a positive 1. Here we have 2 times 2, that's 4, plus 1, that's 5, so x to the fifth power. Here we have 2 times 2, that's 4, plus 1, that's 5, so divided by 5. And there you have it, and then you just keep going. Let's try this one. If we plug in 0, for n, anything to the 0 power is 1. Anything to the 0 power is 1. And then 0 times 2 is 0, so we have 0 factorial, and 0 factorial is 1. So you have to remember 0 factorial and 1 factorial are both equal to 1. So we literally just have 1 over 1, which is 1. So first term is 1. And we know it's alternating, so the next term is going to be negative, right? Because if this becomes 1, then it's just negative 1 times 1. That's negative 1. This is 2 times 1 is 2, so x squared. And then over 2 times 1 is just 2 factorial. We can just leave it like that, 2 factorial. And then if we do another one, make this 2, plug in 2, this is going to be positive, because we know it's alternating. 2 times 2 is 4, so x to the fourth. 2 times 2 is 4 factorial, so at the bottom we have 4 factorial. And you just keep doing that. You plug in 0, you're just left with 1, so x to the first power. Here you plug in 0, you're just left with 1 factorial. We know 1 factorial is just equal to 1, so you really have 1 times x divided by 1. You just have x. And we know it's alternating, so if this term is positive, then we know the next term is going to be negative, because that's what alternating tells us. To get the next term, just increase n. So 1, negative 1 to the first power is just negative 1, negative. 2 times 1 is 2, plus 1 is 3, so we have x to the third. And then 2 times 1 is 2, plus 1 is 3, we have 3 factorial. And then you would just keep doing that. And then for this one, we start at 0. Anything to the 0 is just 1. 0 factorial is just 1, so the first term is just 1. Then we have 1, so x to the first power. Then for the next term, we increase, put in 1, so x over 1 factorial, which is just 1. So it's just x over 1, which is just x. To the next term, you do 2, so you just have x squared over 2 factorial. And then you just keep adding. So the important thing to remember is that both 0 factorial and 1 factorial are equal to 1. And to note, this is true only for when the absolute value of x is less than 1. And that's it for this video. I'll see you in the next.